Okay, so high performance kick-ass web apps. Well, we're a bit late, right? So I don't want to take much of your lunch time and networking time. So hopefully it's how to improve performance on web applications, websites from a JavaScript perspective. So hopefully you know most of these things. So let this be kind of an inspirational talk. So you're just getting inspired to make your applications faster and your users happier. Right, so my name is Stoyan. I recently joined Yahoo Search. Before that, I was working in the exceptional performance team, like a central group of kind of internal consulting, not working on a specific site or property, but just working with the different properties and help them get faster. So I worked on the Slow extension. You're probably familiar with that. I also designed the second version of it, which is a complete rewrite and has more. Actually, I wanted to talk about this, but the thing is it's not out there yet. So it's, from what I understand, because I'm no longer in the team, it will be out any day now. So look out for that. I also did this smush.it tool for image optimization, if you haven't seen it. So why do we care about performance? So there's some numbers that we wanted to, we like to show around. Like there was somebody from Google saying that when their search results page became half a second slower, they saw a 20% drop in traffic. For Yahoo, we did an experiment with a property where we just artificially delayed the page so it doesn't load as fast. So the first few 100 milliseconds were okay, but then when it got to 400 milliseconds, we saw 5 to 9% drop in the full page traffic. What that means is people clicking away or hitting back or going somewhere else before the page is actually loaded. And there is also some other number from Amazon that making their site only 100 milliseconds slower, they saw a 1% drop in sales. So this is quite illustrative. But so if you want to work with your business folks to get some time allocated to work on performance, you can show them those numbers, but take those with a grain of salt, right? Because every application is different, and like for example, in the Yahoo example, the fact that we lost some full page traffic might not actually be make any difference for specific types of applications. If you have an e-commerce site where all you need to show up is the name of the product and the buy now button, right? So you don't really care about the full page traffic. But one thing is true is that when you make your pages slower and you're losing traffic, you're losing visitors, and you're degrading the user experience. At the end, it's all about the user experience. And speaking with different companies, people have noticed that it's kind of a self-regulating system, right? So when you do something stupid in your next update of your application and you make it slower, actually nothing, no one dies, right? So the servers are okay. It's just that you have less traffic. So if you make it slower, then you just lose visitors. You have less sessions, shorter sessions, and people just get irritated from the slow pages. So yeah, when you go into optimization, so that's the first kind of a mantra to remember, that a premature optimization is the root of all evil, right? So or as the Crockford puts it, make it right before you make it fast. So don't just rush into re-engineering, like spending weeks and introducing new bugs and fixing those bugs, and wake up 2 weeks later, find out that it's probably working pretty much the same way. So just make sure that you profile, you measure, you monitor. So basically pick your battles, see where it makes more sense to spend your time. So often the performance optimizations are trade-offs, and this is what I was rereading this 3 Men in a Boat, so what the guy has to say about trade-off. that everything has its drawbacks, as the man said when his mother-in-law died and they came upon him for the funeral expenses. So, you know, everything has like two sides. So, so here's one like a timeline comparison with the life of the typical page 2.0, like with human life, right? You start with a request or conception for humans. So then your server sends the HTML, which is kind of like the human birth, right? So after that, once the HTML, like the backend works, queries all those web services, gets data from databases, and sends the HTML. So then it starts the so-called waterfall. Like in the HTML, you refer to some JavaScript, CSS, images, so all those need to be downloaded. And eventually, the onload event happens. And in typical modern application, that's not the end of it, because then you start initializing your JavaScripts, do some progressive enhancement, replace some DOM nodes, and eventually maybe you get some more XHR data, and eventually the page kind of settles, and the user is engaging with the page. So the thing about the onload is an event, right? So you know when it happens, but what about the user onload? What does the user thinks when the page is loaded is not quite clear. It depends on the page, right? If it's an article, the page is pretty much done when you can start reading the article. You don't care about all the ads or badges and widgets and so on. Or the person may wait until everything like the status bar stops changing, like everything looks settled. So the user onload really depends on the application. So first, let's talk about the optimization you can do to the waterfall, right? Once the HTML is sent. So you can do a group of tasks, like we can group them in to optimize your waterfall. Basically, you want this waterfall to be shorter, right? So that you get all the components in the pages ready in less time. So the most obvious thing is to just put less stuff in this waterfall, like have less elements on the page. Then whatever is left, make sure it's smaller, right? Try to minimize the size of it. Then the next step will be to make sure that there's no blocking going on, right? If one component blocks the others, make sure that it's, don't stay in the way of the other components. And another optimization is to try to start this waterfall process as early as possible. So about the less stuff, so the single most important thing probably is the price of the HTTP request, right? So you just aim to have as less HTTP requests as possible. So that may mean strip features, but not necessarily. You can just combine the components that you already have. So for example, if you have, so this is pretty typical, right? So you have your JavaScript code right here, myapp.js. Then you use a third-party library. And this third-party library has some plugins that you want to use, so you end up with a few script tags. So quite easily, just concatenate all those into a single JavaScript file and have only one file referred in the head. So you just save 3 HTTP requests, right? Just by combining all those JavaScripts. So then you just do the same thing for CSS, right? Yeah. So for the images, use CSS sprites for background images. So basically the rule is anything you can go without, like decoration images, backgrounds, rounded corners, and whatnot. Put those in a sprite, in a single image, and then use CSS positioning to just show part of that image. And you can also use that data URI scheme, so that in using the data URI, you can do both in content images from the image tag or CSS images with a background image. So, so how does that work? So basically you have my PNG, let's say some file. Then, so this is just an example from the PHP command line. You can just get its content and encode it using base64 encode it, and you get this sort of string. Yeah. So then you take this thing and use this kind of complex convoluted syntax, and you say data, column, content type, semicolon, then base 64 the encoding, and then the content of it. So this way you inline the image inside of the CSS, so you don't have to make an extra request to get that image. The same thing with the content images, like you can do it in image SRC attribute and put in the data for that image. So this is really nice, and it even works in IE, but unfortunately in IE starting from 8. So for the others, there's actually a workaround that I kind of recently discovered on a Russian website, and I kind of translated for the non-Russian speaking community. So you can use this thing called mHTML, mime.html. So this is like a email with attachments. Like in one email message, you can have plain text, HTML, one attachment, another attachment, files, and so everything is in one single document. So the same thing for mHTML. So you can basically put images inside of the CSS or even inside of HTML. So what I really find, what I really like about this, that means that especially for mobile application, right, when the HTTP requests, you should, try to avoid them as much as possible. But if you inline all the JavaScript, inline all the CSS, and inline all the images, then with a single HTTP request, you can download the whole application, right? And if you're designing an application for the iPhone, like a web app for the iPhone, you don't really need to care about IE before 8. So another way to have less stuff on the page is to use the cache. All right. So it used to be that people often think, why do I care about the JavaScript and CSS? They're cached anyway. But at Yahoo, we did an experiment which showed that actually the caching is not so universal. And we found out that basically 60% of all the Yahoo users come with an empty cache, and 20% of all the page views are with an empty cache. So the cache is not important, is not as universal as we want it to be, right? So you can do something to help, and that is set those far future expires headers, right? So that means say that, okay, this JavaScript will be cached for the next 10 years. So there's an example saying, okay, the moment it was accessed plus 10 years. So you can do this for JavaScript, CSS, and images. Drawback, of course, is that you cannot change this image once it's cached forever. So all you have to do is change the name of it. So that introduces a bit of complexity, but again, everything's a trade-off, right? So what about inline versus external, right? So on one hand, we say, okay, have less HTTP requests, which means inline as much as possible. But then on the other hand, you can cache those files if they're external files. So here's one solution to have both of them. So on the first visit, you inline, let's say, your JavaScript. And then once the page loads with some timeout in a second or so, then you lazy load the actual JavaScript file, which is the same as that you just inlined in your HTML. And then write a cookie and say, okay, I'm done with the lazy loading. So the next time for the consecutive visits, you read that your server side will read the cookie and say, okay, so this person already has the external file, so I'm not going to do the inlining anymore. So that about wraps it up for the less stuff in the waterfall. So once you have, you eventually settle for some stuff to have in the waterfall. So your next task is to make those as small as possible. And the single most important thing is to gzip, right? Always make sure that you're sending gzip content. So this is a graph shared by Bill Scott of Netflix. So they were not gzipping their static components, and this drop here is the day they turn on gzipping after you join. So basically they saw more or less 50% less traffic with a single improvement. So for gzipping, just make sure that all the text content, like everything that is not already binary, everything that's not an image or PDF or zip. So that means all the HTML, JavaScript, CSS, any textual content is sent gzipped. And it's a really simple change. All you need is a simple sysadmin task to enable gzipping. Another thing for the JavaScript to do to make things smaller is to minify. All right, so this is an example. So what do you have? So this comes from YUI. So you have all your comments properly indented, code and like descriptive variables and so on. Then you write a minifier before you go live, and then you end up with something like this, which is much shorter. It doesn't have any comments or anything. So no new lines. Variables are renamed to shorter names. So at Yahoo, what we use is the YUI compressor. It's written in Java using Rhino, so it knows about your code, so it can pre-optimize some things. So let's say if you have you're concatenating static strings, it will pre-concatenate them during the minification. So it also minifies CSS and has a tolerance for those hacks that we've standardized on using the star and the underscore hack in CSS. It will also add semicolons at the end of if you forget for the CSS. So it does really more than just minification, but trying to improve on like statically as much as it can in your code. So an often overlooked optimization is to minify your inline code as well, not only the external files, but if you have some inline scripts and styles, they should be minified too. So the comparison, so if like some people say, okay, I'm gzipping already, I'm sending the compressed content, why do I care about minification? This is Julian, the creator of YUI compressor. So he took the jQuery, so it was experiment back in August 2007. So it became from 60K, the gzipped version was 20K, and if you minify and then gzip, then you get only 10K. So just do both. And yeah, I have in mind also that there are some clients that do not support gzip, right? So for those, it's better to send a minified version. So talking about smaller components, so this is the smallest component that you can ever get is basically a component without any content, without any body, right? So this is a 204 no content HTTP response. So basically, so this is an example. So people use those for beacons. Let's say if you want to log something, so you want to send a request, but you don't really care about the response, and instead of sending one by one GIF, something like that, or a pixel GIF, then you can just say, okay, just don't send anything, and then you do your logging. So we talked about less stuff. So the next thing is to get out of the way. So you have those waterfalls. You want them as free falling as possible, right? To be as quick as possible. So what can interrupt your and make your waterfall slower is the DNS lookups, because it's not a component by the browser. It still has to look up the DNS for this component. So don't have more than 2 to up to 4 DNS lookups on a single page. Have less redirects because it just wasted time. You request something, and the server says, oh no, go somewhere else, so fetch it from there. And the other thing is to avoid blocking JavaScript. So this is one page that I just by chance is violating all of those. So first, yeah. So first you make a request, and what it does is a redirect. They say, okay, no, go somewhere else and get it from some other. So this binoculars here. This is the DNS lookup. This is a screenshot from IBM page detailer. So then it says redirect. So this icon means okay, go somewhere else. So it fetches another. It does another DNS lookup because it's a redirect to another domain. So then it gets some HTML, and apparently this HTML is doing a JavaScript redirect at this point because it doesn't have that icon, right? So it's redirecting to yet another HTML, and then so basically you can see that maybe 1/3 or at least 1/4 of the time in this waterfall is spent before we actually started doing anything, right? Just redirecting, looking up stuff. And then there's this JavaScript, right? So you can see further down how several components are downloaded in parallel, but this JavaScript here blocks the parallel downloads and doesn't let the others go until the JavaScript is finished. So we all here know that JavaScript blocks, but it also blocks, right? So when you have JavaScript on the page, the browser will wait for the JavaScript to arrive before it continues. And it makes sense because the JavaScript may change the DOM in some way, may do a location, href, redirect to somewhere else, in which case the browser will download components for no reason. So this is changing, by the way, in more recent browsers, but still a large percent of them are the JavaScript is blocking. So what you can do is include the JavaScript with the DOM include. So basically, you create that script tag on the fly, and you set it to src, the source to the file name. So in this case, the JavaScript no longer blocks the download. So the rest of the components can be downloaded in parallel with the JavaScript. So then the question is, because if you do it this way, like the normal way, then your page will know that if you include the JavaScript in the header page, after that in your HTML, you may do some inline JavaScript, which is certain that the code is already there. Your dependencies, libraries are all loaded. But if you do it this way, you don't know. So what about the inline scripts? So you can just set up a simple collection or a registry of all the inline scripts that you want to have. So the first thing is to have somewhere up in the head, you have something simple, just an array that will contain all your inline code. So as you go in the HTML, instead of having inline script which gets executed right away, then you can, instead of that, then you push a function to this registry or this collection of all the inline code that you have. And at the end of your main JavaScript, once it arrives, then it will just loop through everything that you've added to this collection and then just execute all those inline functions. So we saw that JavaScript blocks, but what about CSS? So the thing is that it's mostly harmless. Most of the browsers are fine, but in Firefox 2, CSS will block the download of the other components. And also, interestingly enough, when your script is followed directly by, if your style is followed by a script tag, regardless if it's inline or external script, even if it's an empty script tag, then the CSS will block the downloads. So yeah, just don't do that. Okay, we'll finish this. So yeah, yet another improvement, the last one that I'm going to talk about in the waterfall, is to try to start that waterfall as early as possible. So this is the first diagram. Here is the normal way of your server responds with an HTML page, and then this page refers to some components, and then once the HTML arrives, then the browser will go and fetch the other components. But you can do something to start this process earlier, so move your waterfall earlier. So this is done by flushing the content, the HTML that you already have, while your backend is still pinging or requesting some more data and working on the full response. Then you can, in the same time, start downloading your components. So, for example, this is a PHP example. So it's just a function called flush, right? So in the head of your document, you can refer to your JavaScript, your CSS, and then because it doesn't have any logic here, all right, nothing complex. It's all just static files. So this can be done instantaneously. And then as the server is working on the full response, then the browser can start loading components instead of just sitting idle. Okay, so we talked about all the waterfall stuff. So what about life after onload? So the optimizing the waterfall is the most important thing you can do, but so depends on the application. Then it may be maybe doing a lot more work once everything is there. Like if you have Gmail or some really fat client application, it spends most of the time after the onload. So just a few optimizations that you can do. First thing is to so we talk about lazy loading, preloading, optimizing XHRs, and some JavaScript optimizations. The lazy load, so basically that means anything that is not absolutely required for the first view, just don't load it, right? So just split your huge JavaScript into the absolutely required part and more bells and whistles. So if you have on the page like a Twitter badge or something else that is not really your page, is not really the content. If you have a blog, people come to see the article, right? So let's get the article out of the way, and once the person is engaged with the page, then in the background you start loading the rest of the stuff. And you can also, sometimes you don't actually need some content or some functionality before a user interaction. So if you have some tabs, you don't have to actually have the content of those tabs in the page, because there's a great chance that the user will never click this tab. So just wait for user interaction before you load the extra functionality. So preloading is actually not helping your page, it's helping the page that comes after you, right? So if you're, let's say if you're on a login page and the user starts to type their username, so there's a great chance that, unless they forgot their password, that they'll go into the membership area, right? And in this inside area will have some more functionality, maybe more JavaScript. So as the user types or is looking at your page, then you can start in the background with some timeout, start preloading things that will be required later. So you can preload images, CSS, JavaScript, and you can even preload just prefetch the DNS, right? If you know that the next page will need to look up an extra hostname, just send an image request that returns 204, no content. In this way, just the browser has the DNS cached. So what about the Ajax XHR optimization? So again, like the waterfall, make them small and have less of them, right? So making small, that means don't forget to gzip, because most of the time you send a request to get some JSON data or XML or even text data. So it's mostly just textual data, so just make sure it's gzipped as well. And you'll probably want to use JSON because it's less verbose than XML and make your body of the response smaller. So you can also use the expires header, or just instruct the browser that this response is valid for the next, even if it's 5 minutes or 10 minutes, right? If you don't update the server data that often, and or you can live with some latency, then just when you send the XHR response, you can add the expires header and say, okay, don't ping me in the next 10 minutes because I won't have any more new data for you. And the other thing is using get over post. You probably have seen this discussion. So why is that? It may fall into a kind of a micro optimization, but well, it depends on the page, right? If you have a lot of requests. So a simple XHR request that posts something really small, like you just pass test equals 1. So if you look at, so this is Microsoft Net Monitor, right? So if you look at what's going on here, so you have one TCP packet which sends the request, just the headers of the request, and one TCP/IP packet, one TCP packet that sends the payload, which means just this test equals 1, right? So these are two packets for just one request. Where if you were using get, then that'll be just one request. So this is now no longer true in Firefox 3.1, I believe, but IE and older Firefox versions are still doing it. So when you don't actually want to post anything, if you just want to retrieve data, just use get and not post. So a little bit about optimizing JavaScript code, right? So just be careful with that. Just don't rush into going through the code and just micro optimizing. It's so easy to to just get into it and spend a lot of time and don't actually achieve much. Again, depends on the application, but that's a most common scenario. So actually, Microsoft, when they were developing the IE8, they looked at. Unfortunately, we don't have those tools to do this ourselves, but they look at the top 500 or so pages and looking where the time is spent on those pages. So it turns out that the time spent in JavaScript, which is their JavaScript engine, was something like 7% or something like that for the normal sign, right? And if you have a very heavy, like Gmail, Yahoo Mail, something like that, very heavy Ajax application, then it can go up to, I think it was 14, something like that, the average. So as the Crockford puts it, if we just wake up one day and all the JavaScript engines are indefinitely faster, for most of the sites, they'll just work pretty much the same because you cannot get a much improvement, because that's not where the time is spent in the normal case. But again, your application may be different. So about the local variables, so you know that the global variables are not recommended, right? Because you have maintenance problems and bugs arise because people are sharing the global space. You can, some library, maybe using some globals that you override by mistake. So just get into the habit of using the var inside of the function, and localize the global variables. If you have a lot of work in your function to do with global variables, then you can create a local variable, assign it the global value, and then work with the local. So so here's one example. We have one global a variable, then we have another function in which we define a again, and then another function in which we define a again. So if you execute this piece of code, it will alert 3, right? So if you comment out that last a, right, so then JavaScript will look up the scope chain and say, okay, inside of the B function, I don't have an A, so let me just look it up, and it finds it up there in the other function. So this will alert 2, and naturally the last thing will, when you comment both those local variables and just leave the global variable, it will be consulted. So the idea is to have less of those chain lookups as much as possible. So if you want to refer to a global variable many times inside your function, then you can assign it to a local value. And it works for function, right? Because functions are just objects in JavaScript. So if you look at that alert function, right? So the JavaScript will say, okay, where's this alert defined? It's not here, it's not here. So it must be, have to look up the global namespace. So not having global variables, but having more locals, it also helps the YUI compressor, because it won't rename global variables because it's too risky, right? So the YUI compressor, if you have a long variable name, it will minify to a, let's say. But if you have, like in the YUI has yahoo.util.dom.getxy, so the YUI compressor will not change the name because it's a global, globally accessible, right? So it's risky to rename any of these because there'll be breakage. So yeah, so it's just be careful with that and don't fall into too much micro optimization. But where it's important is when you have a lot of DOM access, right? So basically that's where most of the time in the average application is spent, is modifying the DOM, right? And DOM is the most expensive part. So if you just have like a exaggerated loop of 100,000 iterations and just hitting just getting the head element pointer to all the head elements, right? Get elements by tag name. So if you do this, you can better write it like that, where you create a local variable called get, pointed to that global method, and then loop through that using the just a local reference. So this thing is 4 times faster than if you don't use the local variable. So again, so when you touch the DOM, again, just be careful. And sometimes you touch it implicitly, right? In here, I'm looping 1,000 times, adding to the document's body in HTML. So in this case, for every iteration, I'm touching the DOM twice, once to read the value and once to update the value. So if you do it this way, where you just have a local variable, you update that local variable and touch the DOM only twice, right, instead of 2,000 times. So this is actually quite faster. It's 1,000 times faster than if you access the inner HTML directly. So it's quite a change. So the other thing is to clean up after yourself, right? Because when the garbage collection runs, that may cause a noticeable slowdown, right? So what you can do is, when you're done with objects or their properties and they're big and you know that you no longer use them, just hint and use the delete operator to to say that, okay, I no longer need that. And so the same thing with the DOM elements, right? So when you say, okay, remove this DOM element, the remove child method will return a reference to the removed element, right? But in most cases, you don't need that, so why have it just lying around? So the better way to remove nodes is just to prepend it with the delete operator. So as soon as this child is removed, you also delete the reference to it. You no longer need that. Okay, a little bit over time. Branching during the initialization, right? So I guess everybody at some point of their development life with JavaScript has done something like this. So attaching events, right? Is the add event listener supported? Yes, then use it. Oh, it's not, then for IE, then use attach event and so on. So every time you use this my event function, right? Every time there's this check performed over and over again. So instead of doing this, then you can do it only once. So when you define the function, you say, okay, if add event listener is supported, then you define your my event function to use that. So and this is basically defining the function depending on what's supported and whatnot. So every time then you use my event, it will no longer check every time is this supported or not, and so on. So a slight variation of that is the so-called lazy definition. So inside of your my event function, the first time you call it, it will override itself depending on what's supported, right? And then return then execute, right? So if you don't use it, this check is never performed. But if you use it, the first time you use it, there's one check, and then from then on, there's no ifs. Memoization, if you have like expensive, really complicated calculations going on, and there's a chance that things will repeat, so it makes sense to cache the already calculated value. And because JavaScript functions are just objects, right? So you can add properties to them. So in this case, I'm adding a cache property. So the first time, so you run the function with some parameter, and it has some complicated task to do. So it checks first, consults the cache. Has this thing already been calculated at some point of time? No, it isn't. Then you start your complicated task. Once you're done, you write the result. It can be a single value, it can be an object, it can be anything. You write this to the cache, so the next time you call the same function with the same parameter, there's no additional calculation. The threads, JavaScript is a single-threaded language, so when you do some really intensive computation, then the whole UI freezes. It's not really friendly. So modern browsers like Firefox 3.1, Safari 4, they support web workers. Like, I think it started with Gears, but now it's native for the browsers. So you can have a worker thread, right, and then send exchange messages. So you let this complicated task work in the background, and then get a notification when this is done. And for older browsers that do not support that, there was this set timeout approach, because with set timeout, you're releasing that main thread, right? So you do a chunk of work in your function, then you schedule with using set time. You schedule that you run again in just 1 millisecond, which is enough for the UI not to be locked and irresponsive. So you just do work by chunks. So this is what we covered for live after unload, lazy loading, preloading, better XHR, and some JavaScript optimizations. And the last thing, 1 minute, I was going to talk more about YUI 3, but there was a beat track discussion. So I'm just going to say a few words about the performance improvements of YUI 3. So in Yahoo Search, we're excited about it because we're using YUI 2, and actually Ryan, one of the developers, went and just commented out the things that we don't need, because YUI 2 comes with, okay, this is the functionality, but we don't use all of this. So in the YUI 3, first of all, it's lighter, so it's less kilobytes over the wire, but it also is more more modularized, and it has modules and submodules, so you can more specifically define, okay, this is just the things that I need. I don't need all of these. So fine-grained control. And there's configuration utility. You can say, okay, I want this, this, and that, and to give you URL that you can use. So they took also, it's faster. They took the YUI team took the opportunity to refactor, and like I said, you can have these modules. So they can either be served with what they call a combo handler. So this is if you host your libraries at the Yahoo APIs domain. This combo handler will merge all the little modules that you want, will merge into a single file and minify them, so you don't have to worry about minification and concatenation and so on. And another way to load YUI3 functionality is this self-populating. So you just include the minimum, the YUI loader, and from there, when you can say, okay, I want the animation module, and it will actually go ahead and fetch it for you. So yeah, that's all I had to say. Sorry, 10 minutes late. Okay, thank you very much. Yeah, let's get some lunch.